Today we are going to talk about Gauss's law. I'm going to demonstrate Gauss's law using this apparatus here. It's known as Faraday's ice pail. What this is, it consists of two concentric cylinders. As you can see here, there's an inner cylinder and an outer cylinder. The outer cylinder is connected to electrical ground. We're going to measure the electric field between the two cylinders using voltage. Voltage is a proxy for electric field. I'll explain that in more detail in class. So we begin today. I'm going to start off by grounding everything. I will ground the inner and outer cylinders together. We have 0 volts between them, as you can see here. What I'm now going to do, we're going to investigate Gauss's law. I'm going to insert an object in the center here. We'll see what happens to the voltage. I put this object in here. There's a whole lot of nothing going on. It's sitting right about at 0 volts. I'll take another object, insert it in here too. That is also sitting right about at 0 volts. There's not much going on, not very interesting. Let's make things more interesting. I'm going to take these two different objects. I'm going to rub them together now. Rub vigorously. Rub, 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 rub. Now I'm going to take the black disc, I will insert it in here. We'll observe now, we're seeing negative 28, 29 volts between the two cylinders. I'll bring this out. I'll put in the white one. We see a positive 28 volts. You need to do the analysis. You need to use Gauss's law and see what is happening when we put the charged object in here. Find the net charge on the charged object, on the inner cylinder, and on the outer cylinder. Find the electric field at every point using Gauss's law. One last thing I want to observe, I want to show you, if I take the two objects, put them in together, we see our voltage is basically at 0. Why is that the case? What does Gauss's law tell us about what happens if I have two equal and opposite charges? Notice when I rub the two together, I was transferring charge from one object to the other. The net charge, total charge is conserved, so the net charge stays the same. All we have is negative charge electrons being transferred to one object, positive charge left behind, where the electrons were left behind from the other object.